Hi everyone, today in this video let us discuss the topic Introduction and Static Hashing related to the subject Data Structure and Algorithms. Introduction and Static Hashing. Introduction to hashing. Hashing is a technique used in computer science to efficiently store and retrieve data. It involves mapping data elements to fixed size values called hash codes. Hashing is widely used in databases, file systems, and data structure for fast data access. What is static hashing? Static hashing is a type of hashing where the hash table remains fixed throughout the lifetime of the data structure. It uses a fixed number of buckets or slots to store data elements. Each data element is mapped to a specific bucket based on its hash code. Advantages of static hashing. For fast data access, static hashing provides constant time access to data elements regardless of the size of data set. Efficient memory usage. It uses a fixed amount of memory which is known in advance, making it memory efficient. Simple implementation. Static hashing is relatively easy to implement compared to dynamic hashing technique. Example, list is equals to 11, 12, 13, 14, 15 using hash function x modulus 10. So using a hash table which is having 5 slots, and in this slots 11 modulus of 10 is 1, so it is placed in one first slot, and 12 modulus of 10 is 2, so it is placed in second slot, and 13 modulus of 10 is 3, so it is placed in third slot, and 14 modulus of 10 is 4, so it is placed in fourth slot, and 15 modulus of 10 is 5, so it is placed in fifth slot. Disadvantages of static caching. Limited flexibility. The number of buckets is fixed, which means it may not adapt well to changing data sizes or distribution patterns. Wasted space. If the data distribution is uneven, some buckets may remain empty or ever few elements, leading to wasted space. Performance degradation. As the data set grows, the hash function may become less effective, causing more collisions and degrading performance. Hash functions in static caching. A hash function is a crucial component of static caching. It takes an input data element and produces a hash code, which determines the bucket to which the element will be mapped. The hash function should be deterministic, meaning it should always produce the same hash code for the same input. Input Fox using hash function hash sum is dfdc d3454. The red fox runs across the ice hash function, and the hash sum is 52ed879e, and the red fox walks across the ice hash function, and the hash sum is 46942841. Collision resolution techniques. Collision occurs when two or more data elements are mapped to the same bucket. There are several techniques to handle collisions in static caching, such as chaining, open addressing, and linear probing. Chaining involves maintaining a linked list of elements in each bucket, while open addressing searches for an alternative bucket to place the colliding element. Chaining collision resolution. Chaining resolves collisions by maintaining a linked list of elements in each bucket. When a collision occurs, the new element is added to the linked list in the corresponding bucket. Retrieval involves searching the linked list to find the desired element. Open addressing collision resolution. Open addressing resolves collision by searching for an alternative bucket to place the colliding element. When a collision occurs, the algorithm probes the next available bucket in the predetermined sequence until an empty bucket is found. Retrieval involves sequential search the buckets until the desired element is found or an empty bucket is encountered. Collision resolution using open addressing. There are four types. There is quadratic probing, double hashing, random probing, and informant analysis of hashing. Linear probing. Linear probing is a common open addressing technique. It probes the next bucket in a linear sequence until an empty bucket is found. If an empty bucket is not found, the algorithm wraps around the beginning of the hash table and continues the search. Linear probing example. Insert 76. 76 modulus 7 is 6, so it is placed in the sixth slot. And insert 93. 93 modulus 7 is 2, so it is inserted in the second slot. And insert 40, 40 modulo 7 is 5, so it is inserted in the fifth slot. Insert 47, 47 modulo 7 is 5, already fifth slot is filled, so it search in a linear sequence and zeroth bucket is not filled. So it inserts 47 in the zeroth bucket. Insert 10, 10 modulo 7 is 3 and the third bucket is empty, so it inserts 10 in the third bucket. And insert 55, 55 modulo 7 is 6, since 6 bucket is already occupied, it search in a linear sequence and the zeroth slot is already occupied by 47, so and the next slot is 1 which is not occupied, so it places 55 in the first slot. Performance considerations. The performance of static hashing depends on various factors, including the quality of the hash function, the data distribution, and the collision resolution technique. A good hash function should distribute the elements evenly across the bucket to minimize collisions. The choice of collision resolution technique can also impact performance, with chaining generally better for heavy loads and open addressing better for light loads. Static caching applications. Static caching is commonly used in databases to index and retrieve records efficiently. It is also used in file systems to store and retrieve files quickly. Static caching can be applied in various data structures such as hash tables, dictionaries, and associative arrays. Static caching. Hashing provides a means for accessing data without the use of index structure. Data is addressed on disk by computing a function on a search instead. Conclusion. Static caching is a technique used to efficiently store and retrieve data in computer science. It involves mapping data elements to fixed size values called hash codes. Static caching offers fast data access, efficient memory usage, and relatively simple implementation. Static caching versus dynamic caching. Here, static caching and dynamic caching example has been provided. Thank you.